All right, algebra students, we've been working a little bit on word problems, and at this point, there's really two different types of word problems that you need to worry about. And I want to just show you a quick example of each of them and then try to think about why they might be a linear word problem. So the first type I like to think of as change over time. And so an example might be something like a 20-gallon tank leaks, I don't know, let's say it leaks 3 gallons per minute. This is a change over time because it tells us what we start with and it tells us how it changes over time. And so when you have a problem like this, what you're looking for what do you not know in the problem? And what you don't know is you don't know a specific time and you don't know a specific volume that's at that time. You know what it starts with, you know how fast it changes by, but you aren't told like how many minutes you should care about. Do you care about 3 minutes, 10 minutes, 1 minute? You don't know. And you don't know how many gallons you should care about either. So the things that you don't know specifically become your variables. Those are the things that can change in the problem. And so let's identify two variables. In this case, x can be the number of minutes and y can be the number of gallons. Okay? And those are the variables because they aren't specified in the problem. They're not given to you, and because they can change and you still have a valid situation. So the way I think about this is that your equation, I'll type it over here, your tank starts with 20 and it loses 3 gallons. Well, 20 minus 3 is 17, but it's not like it only went for 1 minute. It loses 3 gallons for every minute. So if it's 3 minutes have gone by, you do 3 times 3. If it's 5 minutes, you do 3 times 5. If it's 8 minutes, you do 3 times 8. So however many minutes go by, you multiply that by x, because x stands for the minutes, and that equals the number of gallons in your tank. And you can see that there is a nice straight line 20 down here. All of the points that are on the line are called solutions. Well, this is a big idea. I really want you to have this idea in your head that points on the line are solutions. So when I look at this line, I can see a couple solutions. 0, comma 20. Now, it's not that 0 is a solution. It's not that 20 is a solution. It's that those two numbers together are one solution. You need two numbers because there are two letters in the problem. So the two numbers 0, comma 20 make one solution. Another solution I can find if I slide down to when x is equal to 1. It will let me. 1, comma 17. That's another solution. Down here, uh, 2 comma 14. That's another solution. In fact, Desmos can do this for me kind of nicely. If I just go here and make this into a, oops, how do I do that? I thought I could make it into a table. There we go. If I make it into a table, is this going to work for me? Maybe not. I thought there was a way to make Desmos make it into a table. That's okay. Well, regardless, the point that I'm trying to make is that every point on the line is a solution to the problem. So that's one style of word problem that we're doing where something is changing over time. The other style of word problem that we're doing is when two things combine to make a total. So for example, maybe you go to the store and you buy almonds for $5 a pound. $5 per pound. I don't even know if that's reasonable. And you buy, I think we talked about figs the other day. You buy figs for $6 a pound. That's terrible handwriting. Okay, $5 a pound for almonds, $6 a pound for figs. And let's say that you spend a total of, let's make it $60. There are a lot of different ways that you could spend that amount of money. You could buy all almonds and spend $60. You could buy all figs and spend $60. Or you could buy a combination of the two different items and still spend $60. And so what the equation does is it captures all of those possible combinations. And I want you to think about, what is it that you don't know in this problem? What we don't know is how many things you bought. We know what the cost is, but we don't know how many. So the things that we don't know are what our x and y can be. So we don't know x is the number of pounds of almonds, and then y can be the number of pounds of figs. And it's not important that I called almonds x and I called figs y. That's not important at all. What's important is that I just made one of them x and made one of them y. When I think about this problem, I'm spending $5 for every pound. So I go 5 times x. Because if I bought 10 pounds, I'd do 5 times 10. If I bought 3 pounds of almonds, 5 times 3. But that's not all I'm doing. I'm also spending $6 per pound of figs. When you see like a per pound, that's thinking I'm going to multiply that price per pound times the number of pounds. And the total that I spend was $60. And look what happens as I type in $60. Now we get a nice straight line. And every point on this line is a possible solution. Some of them maybe don't make super good sense when you're talking about almonds and figs. Maybe some of the decimals don't make super good sense. But if you slide along this line, you can see, oh, check it out. 6 comma 5 is another solution. And each of those solutions is a combination of almonds and figs that costs exactly $60. So the takeaways I want you to have from this video is that the things that are unknown, the unknown pieces, those are your variables. Those are your letters. When you're reading a word problem, identify, what do I not know, and use letters to represent the things you don't know. Maybe you don't know how much time has gone by. Maybe you don't know how many pounds of almonds you bought. But you use letters for the things you don't know. The second thing I want you to take away is that the points on the line are the solutions. And it takes two numbers to be one solution. It is not a solution to this problem to say 10 figs. You have to tell me 0 pounds of almonds and 10 pounds of figs. In other words, the point 0 comma 10. It takes two numbers, but it is one solution. So anyway, thanks for watching. Let me know how I can help, and I'll help you out.